In this tutorial, we're going to be talking about one of the most important topics in Grasshopper, which is lists. Lists are what make Grasshopper extremely powerful, but they're also a really easy place to get tripped up. Grasshopper can do many things as easily as it can do one thing, which is something that is generally not true of doing the equivalent operation in Rhino. So what do I mean by that? If you want to build 1,000 lofts in Rhino, you're going to have to run the loft command 1,000 times. With the power of lists, Grasshopper can calculate all 1,000 lofts in one go. So that allows us to create complex systems of many entities fairly easily. But to do so, we need to understand how Grasshopper operates with lists. So let's go ahead and launch Grasshopper, and we'll take a look at how this works. So far, most of what we've seen in Grasshopper when we deal with like a slider, let's go grab one. And I remember in the last lesson I showed that you can use a panel to visualize data. This is a single piece of data, a slider that goes from 0 to 1. I can see what the value is. And you may have noticed that there's some additional information in this panel that may or may not be clear what it's for. So the first of these is this value 0. So what does that mean? It never seems to change. Well, it's what we call an index, which is like an address for the position of the data within a list. And this little black header indicates that we're dealing with a list, this little gray header, I mean. This we won't be talking about today. This is covered in a different tutorial on data trees, but this is we can think of this as the name of the list or the address of a particular list. So how do we create a list, first of all, in Grasshopper? There are a number of components under set and sequence that create or operate on lists. In fact, a lot of the list-related stuff will live in this tab. And the two that come up all the time in Grasshopper are range and series. I'm going to grab both of these and we're going to look at them. So if I hover over them, we can read their description. Range creates a range of numbers. That's not super helpful. And series creates a series of numbers, also not super helpful. So let's understand how these work and what they mean. So I just deleted my slider with the delete key. If I plug this in, we'll see that we are getting a list of numbers from 0 to 1. And you'll also see that this starts to illuminate the purpose of the number to the left of this little vertical bar. When we create a list of data, several things happen. One is that the wire becomes a double line. If you only have a single number, like if we have a slider, you'll see that it's a single wire. But when we have a list, we get a double wire. And we can see that in addition to the actual values, the actual data that's in here, we also see the index next to it. One thing to know about indices is that they start counting from 0. 0 is the first number. This is very common in all kinds of computer science and other programming environments. The first thing is the 0th thing. And I have 11 numbers in this list. So the 11th item is at index 10. So it's useful to keep in mind that there's kind of that one-off difference from what we would think of as the 5th item is actually at index 4. So what are the inputs to range? Range asks for a domain of a numeric range and a number of steps. So if we right-click the domain and say set domain, you can see that it's specified in this text form as like 0 to 1. If I change this to be from 5 to 10, it's going to change such that the first value we get out is a 5 and the last value is a 10, but it steps evenly in between. The number of steps is actually 1 less than the number of results we get. This is, if you look, it says 11 locally defined values, even though our number of steps is 10, because in fact it's treating a step as like the step between each number. So that can be a little bit confusing. It's just something to keep in mind. If I change this value, if I say, get me bit from 5 to 10 in 5 steps, it will do so as integers. If I say do it in 100 steps, it will change the size of the increment such that these are all evenly spaced. Series works in a very similar fashion, except it, rather than spanning a known domain, it uses slightly different information. It uses a start value, the first number in the series, a step size, and a count. So by default, it gives you a count from 0 to 9, because the count is 10. So this one actually does produce 10 values if the count value is set to 10. And I can change the start value to be something else, like let's make it 1,000. And then this will start counting at 1,000. And then if I change the step size, then it will count by whatever I specify. So let's count up by 25. So it's going to do 1,000, 1,025, 1,050, 1,075, and so on. So these parameters control how these number lists are generated. I think it's also useful to see this in a geometric context. And to do that, it's going to require us to think a little bit about how Grasshopper uses lists. So far, we're just creating a list. We're only supplying single values on this side, but we're getting a list out the other side. And in fact, it's useful to hover over this output and see that this is a component that creates a list from single values. You notice that this says domain D, this is steps N. This one says range R as list. So that's a little visual clue that it actually, when I started learning Grasshopper, it took me a really long time to notice, but it's a really useful thing to identify when a component is going to create a list on your behalf. So what can we do with this? We've already seen how to create points, or how to create a point, using the vector tab point construct point. And this is going to create a point. See, solid wire, single value, based on the single values that come out here. But if we take a component that creates one thing for every one of its inputs, so we have one input, or one value, one value, one value, and we get one value out. If we supply it a list, like our range, we'll get a list back out the other end. So because this domain was set up to be from 5 to 10 with 100 steps, we will get back 101 points whose x position starts at 5 and ends at, what was it, 10? 10. I'm going to turn on the grid and set this to a different viewport just so we can see this is starting at x equals 5 and ending at x equals 10. And maybe I'll put a slider on n in order to change the spacing of this just so we can see a little better. I'm going to set the max to be like 50 and the min to be 1. And we'll make this our count. If I'm taking my own advice, this should also probably be set to an integer slider. So with one step, we get 2 points. And as I increase this, those are going to be added within the range, which is fixed, as I go. If we do the same thing with series, I'm going to reset this to a default series by just deleting it and creating another one. This time I'm just going to double click to search, create a series, and I'm going to create another one of these. I'm going to copy paste and put this in as X, and I'm going to hide the preview of this. So it's useful to connect the kind of what the numbers are doing to what the points are doing. So because a series works on a start value, a step, and a count, it doesn't grow inside a bounds the way range points do. It grows to the right. So let's look at this. Our start value is 0. Let's make this, let's copy our slider. If I set it to 1, then our value will start at 1. As I move it, it's basically just going to move the whole set left and right. If I change the step size, it's going to control the size of the step between each one, but not change the count. And if I control the count, then it's going to control how many points I get. So if I go down to 1, I get 1. If I go up to 11, I should get 11 points. And you can see how manipulating this one, the kind of existing ones stay in position but grow out to the right. And if I turn off the preview of these points and turn on the preview of these points, their ends stay fixed as I manipulate the count, but their spacing and their count change together in order to create a kind of even step, because we're actually working on the specified step. So just useful to keep in mind the difference between those two ways of creating numbers. So we've seen that we created a list of points. So what happens if we supply that list of points into another component that also creates something? So let's create circles. If I go to curve, primitive, circle, and supply these points as the base point of a circle, remember that if I hover over this, I get plane P, radius R, circle C. Those are all single items. If I plug this in, which normally gives me a single circle, when I plug in 8 points, I'll get back 8 circles. So basically, any component that operates from single items to single items will produce a list of values if you give it a list. So this is pretty cool. We've just made 8 circles, and in fact, we can control how many circles we get by adjusting this range. And now the next question is, what if we wanted these circles to have different radii? So what if we wanted to control the parameters of these circles? So radius right now has a single value set to 1. If I create a slider, I can change the radius of all the circles at the same time. But what if I want them to be different? When you have a component with multiple inputs, and you want to have the kind of corresponding outputs be different, you want to supply multiple lists to the input. So what do I mean by that? If I have different points and I want different radii for each point, I need to supply a list that matches this one, meaning a list that has the same number of values. So we actually already have a list of numbers, which we can use as a radius, that is has the same count as our points. We've got from 0 to 11, so that means there are 12 of these. And if I plug these in to be the radius of the circle, then it's going to create now 12 circles with 12 different radii at 12 different center points. And what's happened is that this is where indices become really important. It took the radius at index 0, and I'm going to copy paste this and plug it into my point, and the point at radius at index 0, and it matched them up. So it basically said, make a circle from the 2 things at index 0 and spit out a circle on the other end also at index 0. So an index is a way for us to map back and forth along the kind of tree of data as it gets created to understand where stuff came from and how it came to be. So I know that the circle at index 8 is created at point at index 8. So it has a center at 8.600, and it has a radius of 8.6 because that's the radius at index 8 as well. So one property of creating a bunch of points whose x-coordinate is equal to their radius for these circles is that they all kind of line up at 0, which makes sense. But what if we didn't want these to match exactly? We could create a new list of numbers. So let's try that. Let us create a range, another range, and let's make sure it has the same number of values. This is really important. Whenever a component is taking multiple inputs, a good rule of thumb is if you have a list with n items, then you want all of the inputs that take a list to also have n items. Because what would it do if you had 4 points and 2 radii? What's the kind of logical interpretation of that? The answer is you almost never want that. There is a behavior that happens, and I'll show it to you in a second, But typically the rule of thumb is for every input into any component, you want to make sure you have either n items going in or one item going in. Things get a little more complicated when we start to talk about data trees, but that's a more advanced topic. For now, suffice it to say that you always want either n items or one item for every input into your component. So if I supply this list, now this radius, this range has a different base range. So it goes from 0 to 1, meaning the first circle has a radius of 0. We can see that Grasshopper is going to tell us that means it's an invalid circle. What does it mean for a circle to have no radius? It's not a valid circle. So we can actually construct a domain either by setting one here or creating one ourselves. Under, I'm just going to search for it, domain. There's a component called construct domain where we can control the domain, and nothing changed here because this already has that default value from 0 to 1. But if I plug in a couple sliders here, now I can see how this is affecting. Basically, if I have a domain from 0.25 to 0.25, then my range values are all going to be 0.25, and my circles are all going to have a radius of 0.25. If I make this bigger, it'll get bigger on the other end. If I flip them so that the start of the domain is smaller, I can actually make these circles get smaller as we go down the list, because Grasshopper is just blindly matching the first item to the first item, the first point to the first radius, the second point to the second radius, the third point to the third radius, and so on. So let's create another example that sort of works this way. I'm going to move these aside, and with all of them selected, I'm going to right-click the canvas and choose Preview Off. I want to create two lines, and then I want to connect the dots between them. So let's do this. We're going to create a point. I'm going to use this point parameter, place it on the canvas, right-click it and choose Set One Point, and I'm going to click right here. And then I'm going to create another one and do the same thing slightly over to the side. Set one point over here. Then I'm going to use the line by start direction and length component from the curve tab under primitive. Line SDL stands for start point, tangent, and length, or start point, direction, and length. So this is my start point. My direction is going to want to be the y-axis, the positive y. So I'll just create a unit y component, double-click search unit y. And the length, I'll plug in a slider. Let's make it 10. Another useful shortcut when you're dealing with numbers is that if you double-click and type a single number, you will get a slider automatically that has that value. So that's a really nice shortcut to quickly create numbers on the canvas. So I'm going to copy this line component, and I'm going to plug in the second start point. And I'm going to turn off my grid so it's easier to see. We've got this line, we've got this line. So I'm going to divide this line into points. If we go to curve, division, divide curve, let's inspect this for a moment. This is a component that takes curve C, count N, and kinks K, and produces points P as list. So it's producing a list of values from single items that are provided. So if I provide this curve, it already has a default count here of 10. And I'm going to do the same thing. I'm going to copy and paste and plug in this other one. And so now we've got a list of 10 points over here. Actually, I think it's probably 11 points, 11 points. And so if I want to create a line that bridges between the 2 points, I'm going to use line by 2 points from curve, primitive, line. And I'm going to connect all of these points to all of these points. So in this fashion, we can slowly start to build up these kind of sets of geometry by passing around lists. And the important thing is that we obey the rule that this has n items, where in this case, n equals 11. We've got n points over here and n points over here. Now, what if we don't? What does it look like if we violate this rule? So if I set this divide to be 4 instead of 10, what's going to happen? So curve divide has no problem with that. It's just going to create 5 points because I gave it 4. This one's 11 points because I gave it 10. And what Grasshopper does is that when it is trying to match things up, it's saying, okay, give me the first point and this first point and make a line between them. Give me the second point and the second point, make a line between them. But when it runs out, because it will, we're going to get to the 6th point, I think. So this one has 11. And this one, here, let's copy and paste, has only 5. So it's going to go line, 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 line. And then, because it has run out of lines on this side, it's just going to repeat the last item until it reaches the end of the other list. So that is why we see a nice line, a nice line, a nice line, a nice line. And then up here, all these other lines that are connecting to the last item. So there are very, very rare occasions where you would ever want this behavior. It's called longest list matching, and sometimes we actually want to set it up explicitly. But as a rule, you almost never want to have lists of different lengths going into the same component. So as long as I pair these up, use the same value for both, then I will be sure to get an equal number of A points and B points, and so I'll get a sensible result. Let's see what else we should look at when it comes to lists. So one thing we might want to know is how long is a list. So if we go to the Sets tab under List, we can use a component called list length to find, actually let's do it off our lines over here, to find out how many lines we have. So you may be downstream from the decision where you originally decided how many of these things there should be. And so using list length is a way to just quickly say, okay, I know I have 11 lines. And this can be useful if we want to generate parallel lists. So let's say we now want to create let's just give each one of these a name. Let's create some text characters. So another component from sets sequence, in addition to the ones we saw already, which were range and series, is char sequence, which creates a sequence of characters. If you look at it, the list it produces is A, B, C, D, E, and so on. And this one also takes a count input. So if we supply this and actually, let's just use the points at one end of one of these, which should have the same list length. We can use a text tag component. I'm just going to search for tag. Note that there are a couple of these. There's the 3D one and just the regular one. We're just going to use the regular one, which wants a location and a piece of text. So I plug in all these points and plug in this text. And then I'm going to right-click this and make it larger just so we can see, and I'm going to hide the points as well. It's going to go A, B, C, D, E, F, G, H, I, J, J. And the reason we get that doubled up J is the exact same behavior we just saw. We're trying to put 10 letters on 11 points. So whenever you're trying to create a parallel list, it's useful to use list length so that I'm going to set the count of this list to be equal to the list length that I have, which will guarantee that no matter how many of these I have, I wind up with the right number of points corresponding. Now, you'll also often see a situation where you wind up with like too many points or too many letters, let's say. And that's going to look like this, where it's going to go, okay, first letter at the first point, second letter at the second point, third letter at the third point, fourth letter, and then fifth and sixth and seventh and eighth. And it's going to put a bunch of things at one point. This is often a good visual indicator that you've got a list mismatch issue. A few other things we can do with lists. One thing we can do is we can reverse them. So I can take this list of points and I can flip its order. So let's, under sets list, we're going to find reverse list. And this is going to transform that list I had before. So if I plug in my lines now, it's going to take the first one up here and plug it into the last one, and so on. So as I create this, it's going to sort of span the difference between them. One other thing that is really useful is to be able to input lists with a panel. So I'm going to start a fresh definition just because we've got a lot of stuff going here. So I'm going to do File, New. And I want to create some points according to some pattern that maybe is not that easy to reason about computationally. I just know I need a point at 0, and a point at 10, and a point at 11, and a point at 15, let's say. So a panel is a really good way to do this. If you double-click your panel and type these values separated by a return or enter or carriage return, a new line, basically, we can do 0, 10, 11, and 15. Now, it might seem silly to do this, but what happens if we plug this value into another panel? Because you'll notice that when you enter something directly into a panel, it doesn't show you the stuff like we saw before, the little heading and the index. But if you plug data directly into a panel, you will see that. And what you'll see is that, in fact, we only have one item, which is the entire text string 0, 10, 11, 15. When what we really wanted was one item for 0, one item for 10, one item for 11, and one item for 15. So the way that we accomplish that is by right-clicking the panel and disabling this multi-line data parameter. This is often really confusing to beginners because the wording is not super clear. But if you turn off multi-line data, it basically treats every new line as a new piece of data. Otherwise, it will incorporate the enter or return character in the data itself. So once I've done that, we have the queue to our list. And now we can create some points, let's say. I'm going to use vector point construct point. And it's going to create points. Let's make it the y coordinate at y equals 0, 10, 11, and 15. And oftentimes, this comes up all the time when I'm building Grasshopper definitions. I'm just going to have some important data that I need to set up. Like this is called, base, mid 1, mid 2, and top, let's say, are going to be the names of these points. So same thing, right-click, undo multi-line, and I can use the tag component that we saw before, text tag, to create text tags at those points. And simply because I know that y equals 15 is at index 3, and I also have the word top at index 3, I can see this text getting placed in the right location. So it's really useful to keep an eye on your indices and kind of match what you need. So the last thing we'll do is we're going to look at how you merge lists together. So let's create some lines off of these points. So I'm going to use that component I showed before, which was line from start direction and length, or SDL is how I usually search for it. And I'm going to make this list of points the start point. I'm going to make the tangent direction the x-axis, which it actually, by default, it's the z-axis. So let's make it a unit x. And then I'm going to supply one more list that I'm going to manually input. And I'm going to say, let's make it 5, 10, 10, and 5. Right-click, turn that off to be multi-data. And if we make this list of values the length, we'll get a line of length 5 at the first point, 2 of length 10 in the middle, and 1 of length 5 at the end. And so now we can do something like loft this together. And maybe we want to make it into a straight loft just for fun. Now, sometimes you will have a scenario where you actually want to merge multiple lists together. So just for the sake of argument, let's create one more line a different way. I'm going to use SDL. I'm going to say set one point, and this one's going to be up here. And I'm going to set its direction to be x. I'm going to use the same x I had before, and I'm going to make a slider which is like 14, let's say. So if I wanted to loft between all of these and this one, I could do it a couple ways. I could hold down Shift and plug these in, which is just going to basically append it to the end. But the difficult thing is that you don't always know just from looking what order this is. You don't know whether this line comes first and then these come after. So I like to use the merge component because that allows me to be very visually explicit about the order of the list. All merge does is it takes the stuff that goes in the front and it merges it together into one list at the end. So if I plug in this list as D1 and this line as D2, it will create a new list that puts this one at the very end, and it will have the same result in this case. So now I can control this one independently, and these are controlled with sliders. So if I make this 12, it'll do that. So that's just one more tool in your arsenal for kind of working with lists, and there are often cases where you'll need to like insert an extra item or manipulate the items in that list. So that concludes the basics of lists. In order to get into more advanced topics, tune in to the data trees tutorial, where we'll go into scenarios where we wind up with multiple lists of lists. This is the situation that occurs if you ever see a wire that looks like this kind of dashed double weight line. That means you're dealing with a list of lists. It also explains all of this stuff around flatten and graft, but we won't worry about that for now. But if you are interested in getting even more advanced with your list management and manipulation, I would highly recommend checking out that tutorial once it's published.